In this lesson, we're going to look at graphing quadratics, so quadratic equations, which are equations that have an exponent of 2, a highest exponent of 2 on the variable. But before we get into our graphing quadratics lesson, it's important that we review domain and range. So remember that the domain is the set of all of your x values in your domain, and the range is the set of all of your y values in your data. For example, let's say we have this graph that starts at the point, let's see, 2, 1, and then continues off into the right quadrant 1 direction onto infinity, and you can tell that by the arrow. The domain of this graph would be made up of all possible x values that exist on this line as points. So we can see that the point 2, or the x value of 2, lies on the line. And if we were to move over, you would see the x of 3 lies on the line, and 4, and so on. And if we got, even more detail, we could say 2.5, 3.5 lie on the line, 3.1 lies on the line, and so on. So the way we'll write this is it will go on to infinity of the domain values, and we'll write this as this domain goes from 2 to positive infinity. When you write an actual number that's included, you will use a bracket like that. When it's to infinity, it's going to be an open parentheses. So anytime you're writing a number for a domain or range, you use this bracket. And if it goes on to infinity, we'll use a parentheses to close it up. Now the range goes from all the y values that land on this line. So you can see the y value that we start with is 1. And then as I go up from 1, you can see that all of these y's match and have points that would fall on this line. So all of these positive y values would fall on the line. So our range would go from 1 to infinity. So that is a quick review of your domain and range. If you need more than that, you can go back to previous lessons. All right, so when we're graphing quadratics, we're going to make sure that our quadratic equation is in what's called standard form. And we've seen standard form before with linear equations. With linear equations, standard form was ax plus by equals c. So you can still see the components of a, b, and c in standard form here in this for quadratic equations. A is going to be the number or coefficient that's on the x squared term. B is always the coefficient on the x to the first term. And C will always be your constant. So let's say I had 2x squared plus 3x plus 1. A would be 2 because it's by the x squared. B would be 3 because it's by the x to the first. And C would be 1 because it is the constant by itself. And this will be equal to y. We'll be graphing these so we have our x and our y values to represent the infinite points that could potentially lie on this quadratic graph. The reason we need standard form is because we will be using formulas throughout this unit to help us find certain parts of these graphs, and we'll refer to these coefficients by using a, b, and c. And so when we say a times something, that should automatically lead you to, okay, what's the x squared term's coefficient? And that will be your a, and so on. So just to give you a quick overview, the graph of a quadratic is called a parabola. And this is the shape of it. It either opens up or down. Not to be confused with a graph like this. This is not considered a parabola because it's opening to the side. So parabolas open up or open down. So remember I was talking about the parts of the quadratic equation in standard form. So if we notice that a, whatever number is being multiplied by x squared, is positive. If that number is positive, then the parabola will always open up. and it will have a vertex. A vertex is your lowest or highest point on the parabola. The vertex in this case would be a minimum point because it's the lowest point on the whole graph. So I tell you this because as you're graphing quadratics today, and you see that A is positive, you should make sure that at the end of all of your graphing, your graph actually did open up. And if it didn't, then that's a sign that maybe something went wrong in your graphing. The reverse of this is if A is negative. So if whatever number is in the place of, or times x squared is negative, your parabola will actually open down. And that vertex or highest point in this case will be a maximum. So you've seen a couple pictures of parabolas, and I would like to ask you if you think that they are symmetric. And so hopefully you are seeing that yes, they are. Parabolas always have a line of symmetry that we could fold on top of itself and have realign with the other side. So yes, parabolas are symmetric. And this is important because this symmetry will really help us more quickly graph quadratics if we understand and know that quadratics will always be symmetric. So the line of symmetry for a parabola is called our axis of symmetry. So we've got an x-axis, a y-axis, and now we have this axis of symmetry right here. And the axis of symmetry will always be vertical. It will always be a vertical line. And this line represents the line that we could fold our quadratic graph on top of itself or fold it over as that line of symmetry. Incidentally, the vertex, that remember high or low point, is the only point that ever falls on the axis of symmetry. All of the other points of your quadratic will not fall on that line of symmetry. They will be elsewhere in your graph. So the vertex is the only point that falls on the line of symmetry. So if we know that, then what we can do is find our axis of symmetry by using a formula that also would help us get the vertex. So this is going to be an important formula. So the formula for finding the axis of symmetry and coincidentally, again, the x-coordinate for that minimum or maximum is x equals negative b over 2a. So remember how I said at the beginning that a, b, and c will refer to the different parts of your equation in standard form. So what this means is whatever the number is in front of your x to the first term, we'll take the opposite of it and divide it by 2 times whatever number is times the x squared term. This equation is x equals, and when you memorize it, I really want you to remember the x equals portion of the equation as well. Don't just focus on the negative b over 2a. It's really important you remember that this is x equals negative b over 2a because this will also help you get the vertex. And a vertex is really just a point on your graph made up of an x and a y value. So if you find the x part of the vertex, that means whatever this simplifies to, that will go into the x slot of the ordered pair for your vertex. So that's why I want you to remember this is x equals. It's also important to remember it's x equals because this will graph as a vertical lines, and vertical lines always have the equation of x equals a number. All right, so moving along. To graph quadratic functions, we're going to go through 4 main steps. First, and this isn't really part of the steps, but always be sure your equation is in standard form. If it's not, you need to rearrange it so that it is. Really, this is descending order. So do make sure of that before you get started. But step 1 is to graph an equation. First, find the x-coordinate of the vertex using the axis of symmetry. So this is what we just saw. The formula for this will be x equals negative b over 2a. This helps us find the axis of symmetry that we could quickly sketch, and also tells us the x-coordinate of the vertex. Once we find the x-coordinate of the vertex, we're going to then find the y-coordinate of the vertex. So that means whatever this number is, we're going to substitute it in for x into our equation, simplify, and get the y. And so this will give us the entire ordered pair for that vertex. Once we've done that, we will know where that high or low point is for our parabola by the vertex. Let's say it's opening up. And so then from there, we need to get other points on this parabola. So what we're going to do is make a table of some x values and solve for the y values. What we'll try to do is choose 2 points at least that are to the left of your vertex and 2 x values that would be to the right of your vertex and find those points. That way we're getting and seeing that symmetry on both sides. This will help us determine how wide or narrow our parabola needs to be sketched. Finally, once you get a set of points that can be plotted, you'll plot your vertex, you'll plot a couple points to the left and the right. Now you can graph the vertex and points and connect them and sketch that parabola. So here's our first example. We're going to graph y equals x squared plus 2x minus 3. Remember to start by checking that this is in descending order. So I am starting with the highest degree term and ending with the term with no x variable, or it's technically an x to the 0. So we are fitting our standard form. Off to the side, I would recommend starting by stating what a, b, and c's values are from the standard form. A comes from the x squared term, and there's nothing there, so it is understood to be a 1. B comes from the x to the first term, so in this case that's 2. And C comes from your last constant. Please notice that this is a negative 3. C is a negative number. All right, so step 1 is to find the x coordinate for the axis of symmetry. When we have A and B and C stated, this will make this portion of finding the x coordinate of the axis of symmetry, or finding your axis of symmetry equation, pretty straightforward. All we're going to do is fill in the numbers for B and A using that equation x equals negative b over 2a. So in this case, B is 2 and A is 1. So I'm going to write negative 2 over 2 times 1, which will simplify to negative 2 over 2, which all the way simplifies to x equals negative 1. So right there on your graph, you can already sketch that your axis of symmetry falls at x equals negative 1. And I often would show this with a dashed line or a light line. So this tells you our parabola is going to be somewhere along this line. Notice that A was positive, so that also tells you it's going to be opening up. Now we're going to find the y value of the vertex in step 2 so that we can find how high up or how low this parabola will be. So if x is negative 1, we're going to now take negative 1 and replace x with negative 1 everywhere in our quadratic equation that we started out with. So x squared plus 2x minus 3, I'm going to replace the x with negative 1, the x with negative 1 again, and just recopy the rest. Please use parentheses when you are doing this substitution because negative 1 squared is very different than negative 1 squared, right? This would equal negative 1, whereas with the parentheses, this simplifies to a positive 1. So from here, go ahead and simplify. This is positive 1, 2 times negative 1 is negative 2, and bring down your negative 3. So y's value is negative 4. This gives us the entire vertex as the point negative 1, negative 4. So if I were plotting this vertex, I would have it down here. And as you do find these points, I would recommend that you're graphing. I don't have the space to show you all at the same time here, but you should be doing that as we go. Okay, so we've got our vertex at negative 1, negative 4. I'll label that as V. And we know it's going to open up, and we know it will be on our axis of symmetry of x equals negative 1. From here, we need to find some points, some other points on our graph. So we know that about right here is our vertex. So what we're going to do is now look for some of the points that would fall either to the left or the right of our axis of symmetry. So a point that might fall to the left, or an x value that might fall to the left, would be -2 and then -3. To the right, we've got 0 and 1. So notice I'm just starting on the x-axis, looking at my axis of symmetry, and really just going 2 to the left and 2 to the right. And that's how I'm going to determine which x values I use to find some more points. You can use any x values in this entire graph. However, if you chose something like x of 15, you're going to find that your y value is probably way up here, or just really off your grid of the space that you have to sketch. So that would not be an incorrect point. It's just that it might not be in the view that we're looking at. So what I want to show you real quick is a way you can use your calculator to help you quickly find these y values. Now, really, you should be able to substitute -2 in for x everywhere and simplify and solve for y. Then do it with -3, then with 0, then with 1. This really shouldn't take too much time, but another way to do this is to store x as -2. So let's come to our calculator, our scratch pad. So I'm going to store x as -2. So -2, control store x. Oops, I didn't hit x. Okay, there we go. X. And then from here, we'll type our equation, and you're just typing this portion of it because we don't know the y. So x squared plus 2x minus 3. X squared plus 2x minus 3. And your calculator is going to now replace x with -2 each time, and we get that to be -3. Now, this is where this can be made easy, is because now that we've typed our equation in, let's now store x as -3. Hit enter. Now it's going to remember x as -3, and I'm going to scroll up to highlight the equation, hit enter. It recopies it for us and then puts -3 in it, giving us 0 for x, or sorry, for y. And then you can do this with 0, control store, hopefully 0 you can do on your own because 0 plus 0 is -3. And then finally putting 1 in, control store as x, recopy. Oh, it's not picking up my x when I hit it. Recopy this, same equation again, and hit enter, and we get 0. So I show you that not because you really would have needed it for a quadratic equation like this one. However, if x were a fraction or maybe a larger number, that copy and paste tool in your calculator could really make this process a lot quicker. But essentially all we're doing is replacing each x for the x's in this equation up here and simplifying for each y. And we just do that over and over and over again. And so then what we get are several points. So all of these can be written as ordered pairs. And all of these ordered pairs fall on the graph of this quadratic. So lastly, what we're going to do is plot those points we just found along with the vertex and get a nice sketch of what this parabola would look like. Once you get here, just extend the lines up a little bit. It does curve and it does go out in both directions. So just do your best with sketching what that looks like, and please put arrows at the end to indicate that this does continue onward in the positive direction. So lastly, this brings us to determining the domain and range of the graph. And so remember, domain is all of the x values that would fall on this graph. So in this case, we want to think about, okay, if I'm walking across my x-axis here, How many of these x values would have points actually on this graph? So we can see that x of -1 is on this graph. We can see that x of 0 falls on the graph. X of 1 is on the graph. X of 2 looks like it's about there. X of 3 looks like it would fall on this graph if we continued it up, right, and hit it probably about right here. And so you can see that we could keep going, and this parabola is going to keep on extending onto infinity. And yes, it might take a while for us to reach all of the x's, but this is going to keep going up and out slightly, but it will go out. So you're going to see all the x values in the positive direction will fall on this parabola at some point. We can do the same thing going to the left. Here I have x of -2, that's on the graph, -3 is on the graph. If I come here to -4, we can see it landing on the graph, and so on with -5, -6, and we can continue. So when you're looking at that, you can see, okay, both in the negative direction and the positive, all of our x's are actually going to fall or have a point that falls on this parabola. So if I go on forever in the negative direction, that is -infinity, and if I go on forever in the positive, that's positive infinity. So because these are infinities, we use parentheses to show, and from least to greatest, that it will go from -infinity to positive infinity. Our range will be a little bit different. Looking at the y values, you can see, okay, up here, y would have actually 2 points that end up on the graph. So this might be the point, 1, 2, maybe 2.5 or 3, 310 or something like that. But whatever this y is, it is going to fall on this graph. If I look here at 0, y of 0, I have a point, I have 2 points right here actually that have y's of zeros. I can come down here and look at y of -3 and see that yes, there are points that include y of -3. I can come down to -4 and see there is a point that has a -4 of y. However, if I come down to -5 or even just -4.1 or 0.1, you can see that this parabola will never get that low. It will never hit the y's below -4. So because of this, we will see the y's will go up to positive infinity. However, they do not go below -4. So to show this, we will show that our y values, our range, is made up of all y values from -4 to positive infinity. If your parabola were opening down, you would notice the opposite happen, where you would have a y value that you would start with. Well, and I would write it in a different order, but it would reach all the negative infinity, but it would stop at a maximum y value. So in that case, you would write it as -infinity to whatever your number was. Okay, so that's your domain and range. So we've now gone through graphing an entire quadratic equation together. Let's do this one. The equation looks a little bit different because while it is in standard form, we are missing the b term. So another way to look at this one is to see it as -3x² plus, and because it's not there doesn't mean it doesn't exist. It just means that it's 0. So b in this case is 0. So you might say, well, and I forgot I had this, but you might say this is not in standard form and just stretch it out as I just showed with a 0x there, just so you have a number in the place of b that you can use. So to find your step 1 axis of symmetry and the x value of your vertex, we're going to first jot down what the values of a, b, and c are. A is -3, B is 0, and C is 1. And fill those pieces into our standard form. And let me see if I can move this out of the way. Okay, sorry about that. All right, so if b is 0, we're going to write this as negative 0 over 2 times a, which is negative 3. So that simplifies all to just 0. So the x value of your vertex is 0. That also means your axis of symmetry is x equals 0. So we found the axis of symmetry to be x equals 0. Now we want to find the y value of the vertex. So we're going to replace the x's in our quadratic equation with 0 and solve for the y. So negative 3 times 0 squared plus 1 will give us the y. All of this simplifies to 0 right here. So y equals 1. That means our vertex is the point 0, 1. So again, at this point, you should have now sketched that your axis of symmetry is actually your x-axis, and the point 0, 1 is where your vertex falls. Hopefully you noticed your a was negative, so that means that your parabola is going to open down, but we don't know how narrowly or widely it will do that. So that's where we need to now set up a table to get some points to the left and the right of our vertex. So if I'm looking here at my vertex of 0, 1, 2 points right to the left would be x of negative 1, x of negative 2. 2 points right to the right would be x of 1 and x of 2. So that's how I decided on these x values. Again, you can choose any x values, but the ones closest will usually give you y values and points that fall in the view that we're looking at. Okay, so from here, take a moment to replace x with each of these values and get the y's. How about you do that? When you're ready to check, I'll reveal all the y values. So pause and then click play. Okay, so hopefully you went and put all those x's in and found that when x was negative 2, y was negative 11. When x was negative 1, y was negative 2, and so on. So remember, these are all points that can be plotted. And you don't have to write them as ordered pairs, but just since we're starting out, I'm going to show it that way. And finally, we're going to graph. I don't know why it's dragging this. Okay, we're going to graph those different points. So we are able to now connect them. You can see this is a slightly more narrow parabola. We'll get into the details of how to tell when it's going to be narrow or wide later. But this is a narrower parabola opening down, and the vertex was that point 0, 1. The vertex is going to be really helpful for stating the domain and range of the graph, because we do, especially for the range, need to know what that highest or lowest point is on the y-axis. So the domain, hopefully you're noticing, while it will be slow, this will continue on opening outwardly, onto infinity. So all of our x values are falling on, if I were to get out here, right, it is going to fall on this parabola, and I can do this all day. So our domain is, again, negative infinity to infinity, and our range goes from a y value of 1, and this goes down. You can see none of these positive y values are being hit by this parabola. So we will express this as we are coming from negative infinity all the way to 1. Okay. So we'll just write it this way. My pen stopped working, so I had to restart it. Okay, so from negative infinity to 1. And the 1, because it's a number, gets a closed bracket, whereas all your infinities get parentheses. Okay. Lastly, just to show you a quick calculator tip, is that you can check that the vertex that you got is actually the correct vertex for the quadratic equation you're given. So I just wanted to show you this quickly, that in your calculator you can graph your equation. Then you can type menu, analyze, or analyze graph, then select either maximum or minimum. This is referring to, is that highest point, is that vertex a max or a min? And then we'll choose our lower bound and upper bound. I'll show you what this looks like and click OK. So let's say that we were doing that negative 3x squared plus 1. What we would do is come here, come to your graphing scratch pad and graph negative 3x squared plus 1 and hit enter. Once you've done this, you're going to hit Menu, Analyze Graph. And in this case, because it's opening down, we're dealing with a max point, a maximum point. Then we'll click once to the left of that maximum point and once to the right of the maximum point. And you can see that the ordered pair 0, 1 comes up, telling us that this point right here is 0, 1. And that does check out with what we found our vertex to be. So you can always use that if you're doubting your vertex work and whether that's correct. There is an extra practice problem that you can complete if you'd like to do it. You can pause this video, work this one all out, graphing it, and then click play to check. Okay, so for this quadratic, negative 2x squared minus x plus 1, your A was negative 2, B was negative 1, and C was positive 1, meaning that your vertex was the point x was equal to negative 1/4, and then replacing that negative 1/4 and for x each time gave a y value of 9/8. So this is where storing x as negative 1/4 might make it a little bit easier for plugging or substituting in for x and solving for y. Once you find this vertex, you should have roughly sketched about where it fell. And when you're setting up your table, definitely don't use fractions if you don't have to. Just use the next nearest whole or integer number to the left and to the right of your vertex. So that looked like negative 2, negative 1, 0, and 1, giving us these ordered pairs. And here's a rough sketch of what the graph would look like when we plot those points. And finally, your domain and range. Domain, again, is negative infinity to positive infinity, and range would be negative infinity to 9/8, the y value of your vertex. So coming all the way up from negative infinity, and then we stop once we hit 9/8 for the range. And that is the end of our graphing quadratics lesson.